You hear me in the back? Okay. Okay, I'm going to do something similar to what I did last time with showing a couple of videos. There's two of them, and they're both combined shorter than the last four that I did last month. So they need to run together about 35 minutes or so. So we'll be done sooner than we were last time. Also, I tried to prevent some of the confusion we had last time by going ahead and handing out these handouts before we even start. That way everybody should have one. If you don't, I've got some extras. And I thought I would talk a little bit about the subject myself, although this is pretty much very descriptive, the handout is. But I thought I could show you briefly. The handout describes that cloud computing and cloud storage, they're a little bit different. Most people have heard of storage, but they haven't really heard of cloud computing. And so the first part of the handout gives you a description of what that kind of is and how you're really using it without even knowing it most of the time. And storage is sort of optional. You can choose to use it or not. Some people choose not to because they don't think it's very secure, but it usually is. And I use it myself, like I described at the bottom, with Google, because I trust Google. I always have, and I like them a lot. So I use Chrome, and for example, I'll show you how I do. Open this new tab. I could try to show you on my tablet too, but I think that's going to be a pain. So these are my bookmarks, right? I got a lot of them. There's probably thousands of them in there. Whenever I edit my bookmarks, if I use the manager or whatever, or I add a new one in my categories, it gets stored on Google's cloud. And I've got Chrome, my browser, set to sync. So that anytime I log in with Chrome on any of my devices, I've got a tablet, I've got a smartphone, I've got my laptop here, I've got a PC at home. It doesn't matter where. If I log into Chrome, those bookmarks will be the same on every Chrome, on every device. And it's similar with what I mentioned as my contacts. If you go to Chrome, or if you have Google Gmail and you sign into it, you've got access automatically to your Gmail and all these other things. And all you got to do is click on that little square thing, and you can see that, right? And that's all the other stuff. And there's more. You can scroll down, and there's a lot more stuff that Google offers you for free. And one of my favorites is the contacts, of course. I keep all my contacts on there. And I'll show you that. This is my contact list that I mentioned earlier, and it's on the cloud. So again, it doesn't matter what device I use. Whenever I sign into Google, I have access to my contacts because they're in the cloud. And that works with a lot of things that Google offers. So, without that, the two videos I'm going to show you are sort of the after the basics, after you get past, that the internet itself is a cloud, and you get past that part, and you know that you're using it all the time. Like I mentioned here, if you've ever played a game online, you're using in the cloud to play the game. That's cloud computing. Then storage is like I just mentioned here. I can also upload files, documents, which I've done. This handout will be available to any of you. If you go to the Facebook page, you can click on the link there and get this handout and print it out, or click on the links. And the videos will be available on the Facebook groups. So, anyway, you can do, with Google, you can upload photos, you can upload files, pictures, all kinds of things. But what I'm going to show you the videos after, or what's going to be like an after all the basics, and especially the very last one. It's Ray Kurzweil. If you've heard of him, he's a bigwig at Google. He's head of their engineering department. So he'll tell you a little bit what's coming in the future with cloud. Okay, with that, I'll show you the videos. And hopefully the internet will stay on. Make sure we get the sound right.
Fans are slow.
It shouldn't be taking that long. My laptop's pretty fast.
Oh, it says disconnected at the top. Wi-Fi.
There it goes. There it goes. I don't know why it took so long.
How many of you get really, really excited by computer servers?
Can you all hear back there?
I don't think you're telling the truth.
Is it loud enough?
A few of you maybe from the computer science department, but the rest of you, I don't know. Usually it's crickets. Nobody ever raises their hand when I ask that question, and that's, as you might imagine, kind of predictable. But it's okay because I do get excited by computer servers, particularly when they're organized in architectures called cloud infrastructures, or so-called cloud computing. And the goal of my talk today is, I hope, to get even more of you a little bit excited about cloud computing servers, and even more than that, to get you to think seriously about how you can use those and the potential that they represent, and maybe even one step more than that, how you might even have an obligation or a responsibility to think about that. And that's what I call the cloud imperative. Now, it's a little bit like that old biblical statement, from those to whom much has been given, much shall be asked. And you'll have to forgive me because the fact that I went to divinity school for a year is showing now. I'm actually a divinity school dropout who went on to found a cloud computing company. It's called Brightscale. So forgive me for that. But I do truly believe that cloud computing is changing our world for the better, and it's touching all of our lives. Let me throw out a few examples. First of all, think about what NASA and JPL is doing lately with the Mars rover missions, the Cassini probe, sending back images of other worlds to us that are then processed in cloud computing and delivered out over the public web for all of us to see. Or in the field of bioscience, everything from gene sequencing to drug discovery, computed on massive compute grids in the cloud. Think about the social realm. Previous speaker, Matthew Huxtable, talked about the fact that the Arab Spring, that whole uprising was sparked in large part by Facebook and Twitter, services run on cloud computing architectures. Or even in the area of fun and entertainment, everything from the music that we listen to and share to famous movies. For example, remember that Frodo and the Fellowship were able to save Middle-earth in stunning high def, thanks to video rendering completed in clouds. But before I go any further, let's do a little level set. I have another question for you. How many of you feel like you have a pretty reasonable grasp on what cloud computing is and how it works? Okay, that's most of you. The reason I ask is that a recent survey showed that 1 out of 5 Americans has pretended to know what cloud computing is. I don't think that applies to this audience at all. But, further detail, 14% have pretended in a job interview, and 17% of us have pretended to know what cloud computing is on a first date. You try to imagine that scenario. It's a little, hey baby, I know what cloud computing is. So anyway, as a little brush up for all of us, and for those of you who are heading to a second date and don't want to blow it, here's a little background. The phrase cloud computing comes originally from these diagrams in the mid-1990s that were used by engineers up on whiteboards about connecting different data centers, branch offices, workstations, etc. through the internet. And the cloud on this diagram simply represented that you didn't know or care the pathway that the connection took, whether it went through Las Vegas or Chicago or Dallas. You didn't know, you didn't care. As long as the packets in the communication arrived, they were reliably and with reasonable performance. But you know, this concept is, in fact, in simple terms, what cloud computing is about. Same idea, the computing takes place somewhere else. You don't know quite where, and you don't care about that. But this concept is really a generation old by now. So what's new today? Well, about 6 years ago, there was an innovation. It was around the notion of exposing infrastructure, which is a fancy name for computer servers and storage and so on, in new ways. The first part about it was that it was automated. And that means that software programs could talk to other software programs and have them do stuff, like launch a server, terminate a server, things like that. Second big point has nothing to do with technology. It was around the business model. And it was the notion that you could pay as you go for using these resources. Pay by the hour, in fact. And one of the interesting corollaries about that was that it cost the same thing to run one server for 1,000 hours as it cost to run 1,000 servers for 1 hour. And that kind of turned upside down the notion of applying computer power to solving problems. The final point was around the fact that the early cloud service providers did all this and created the illusion that these resources were infinite. And so designers and users of these compute resources didn't really need to plan around scarcity at all. In fact, they could always plan around the notion that there were no constraints. There would always be another computer server available if they needed to use it. And these were really, I would say, revolutionary changes in the way this service was delivered. So going back to how did I get involved? Well, about 5.5 years ago, a half year into this new process, I had a friend of mine and a colleague, Torsten von Eichen, who's really the guy who originally got the idea for RightScale started. He called me and said, hey, I've written a web interface that lives on top of this new cloud computing service called Amazon EC2. Would you check it out? And I went home that evening and fired up my laptop and logged in, created an account, and launched a server. It was, as I recall, a WordPress server, which, as some of you might know, is a piece of blogging software, open source blogging. And about 5 minutes later, it was running, and this was a huge aha moment for me. It was revolutionary to me. I thought, my God, this is so easy, it's so inexpensive, it's going to change the way information technology is delivered and consumed. Because I had been through the old way of buying servers, taking 4 weeks for them to ship, racking and stacking, all that stuff. And in fact, 5.5 years later, our company has now launched nearly 5 million servers on behalf of customers. And you know, that's an interesting number. I think it's nice, it's kind of cool. But more important is what stands behind that. And that is the companies and the solutions that were created on this infrastructure. And if you take a glance over this limited set of companies we've worked with, you can see it ranges from small startups you've probably never heard of to the biggest multinational companies. All of them, however, having one thing in common, which is running from a kind of a startup agile mentality, whether it's a startup company or a startup project within a larger company. And I'd like to call out 2 examples, just to give you a sense, nitty-gritty examples of the kinds of projects being done that perhaps aren't as grandiose as the Mars rover and things like that, but are closer to my heart in terms of helping all of us identify with what can be accomplished. The first one is Animoto. They were actually our very first customer, and it was 5 guys with some experience in the television industry who said, we want to make a service that allows people to take their digital photos and convert them into cool-looking videos. And what they do is they create transition and animation effects that match the music that you choose to go with the videos. And they started out, they built their service on top of RightScale in the cloud, And what happened about a year later, they got a cool idea, which is let's create a plugin for Facebook that lets Facebook users do this. And this graph shows what happens. Essentially what they did is let a user take their Facebook photos, make a video, email it to their Facebook friends, who could then take their Facebook photos, make a video, email it to their Facebook friends. What you can see there is the heart of a viral scenario, right? This was a viral experience. And the graph on the bottom of the display is how many servers they were running over a couple-week period. They were running along at about 50 or 60 servers, and over 3.5 days, they launched 3,500 servers around this Facebook plugin. They were signing up about 20 or 30,000 new users per hour at the peak. And what's interesting about this story and compelling to me is, again, not the technology of automation, but the fact that a business could not have done this. They couldn't have done this without cloud computing. They wouldn't have been able to raise the money, and logistically they wouldn't have been able to rack and stack and configure all of those servers to accomplish this. The next example is even closer to home. It's actually a local company here in San Luis Obispo called Edgify. And it was founded by Andrew DeMille, who's a former colleague of mine and a friend, and his buddy Spencer and some others. In fact, I think they might be in the audience. Can you guys raise your hands there? Edgify is a very cool service. It's a brand new startup. And what they do is they assist with coaches working with athletes, and they make that process a lot richer and more productive. It not only includes kind of a way for them to communicate back and forth in the typical kind of social forum nature, and to communicate over times when they're not working together in person, but it allows for the posting of photos and videos, and most importantly, to track progress over time. And I think this is another example of making our lives better, because if you think about it, it encourages activity, it encourages exercise, and it encourages us to follow a process of thinking about how we progress and improve at something that we're working on. And all of that is goodness. All of the companies that have been very successful at using cloud, in my experience over the last 5 years, have shared a particular kind of approach in common. It's an approach that I call the experimental approach. And that doesn't mean they're going into a lab and doing a science experiment. What it does mean is that they have a particular mental attitude, a kind of a cultural work orientation of building the first iteration of a particular solution, and then getting it out there, learning from it, and iteratively improving it. And I love this image of the history of the evolution of the wheel in human society, because to me it embraces that same idea of taking a concept that you get out there and learning from your experience with using it, and then improving it over time based on what you've learned from the past and based on the current resources and materials that you have available. And I think that this particular approach meshes especially well with the fact that cloud computing provides resources in such an agile manner for all of us to take advantage of at cost that is really quite affordable and achievable for most of us. I think you're all familiar with this guy. This, of course, is Master Yoda from Star Wars. And I had to put his image up today because he, like me, believed that small teams can achieve amazing things in this world. And I think, in fact, he believed further in something called the Force that was helping them. You may or may not believe in the Force, but I'm here to tell you that there is a force behind cloud computing that we can all leverage now, that is available to us in a way that it wasn't even 10 years ago. Master Yoda was famous for saying, "Do or do not, there is no try," if you remember. And it was kind of a bold statement of confidence and believing in what you're doing. I would amend that a little bit to say, try and try again, and keep trying until you can finally do it. And to me, that's in the very same spirit, but a lot more in keeping with this kind of experimental approach that I've spoken of. So, to conclude, I'd like to leave you with one last question. What could you do with 1,000 servers? Or with 10,000 servers? Or with 100,000 servers? And it might seem like a bit of a silly question. Maybe you're not a technologist or a software person, and maybe you're not a geek like me who gets excited about computer servers, although I've never had as many people raise their hands as you did. So maybe those things don't apply, but I hope you do take seriously that these resources are available. You can certainly find people who know how to do the technical part. It's really more a question of what aspirational, creative, new idea do you have that you can go pursue and actualize? And so I leave you with that question, and I hope you take it to heart, even as more than just an opportunity or a potential, but almost as a responsibility and an obligation that we all have to use these incredible resources in one way or another, I hope, to make the world a little bit of a better place. Thank you very much.
As bad as those Microsoft little dots.
I know.
They go round and round and round.
How long did that take last time ever? About 30 seconds or something?
Yeah.
Let me tell you a story. Goes back 200 million years. The story of the neocortex, which means new rind. So in these early mammals, because only mammals have a neocortex, rodent-like creatures, it was the size of a postage stamp and just as thin, and was a thin covering around their walnut-sized brain. But it was capable of a new type of thinking. Rather than the fixed behaviors that non-mammalian animals have, it could invent new behaviors. So a mouse is escaping a predator, its path is blocked, it'll try to invent a new solution. That may work, it may not, but if it does, it'll remember that and have a new behavior, and that can actually spread virally through the rest of the community. Another mouse watching this could say, hey, that was pretty clever, going around that rock, and it could adopt a new behavior as well. Non-mammalian animals couldn't do any of those things. They had fixed behaviors. Now, they could learn a new behavior, but not in the course of one lifetime. In the course of maybe 1,000 lifetimes, it could evolve a new fixed behavior. That was perfectly okay 200 million years ago. The environment changed very slowly. It could take 10,000 years for there to be a significant environmental change. And during that period of time, it would evolve a new behavior. Well, that went along fine, but then something happened. 65 million years ago, there was a sudden violent change to the environment. We call it the Cretaceous extinction event. That's when the dinosaurs went extinct. That's when 75% of the animal and plant species went extinct. And that's when mammals overtook their ecological niche. And to anthropomorphize, biological evolution said, this neocortex is pretty good stuff, and it began to grow it. And mammals got bigger, their brains got bigger at an even faster pace, and the neocortex got bigger even faster than that, and developed these distinctive ridges and folds, basically to increase its surface area. If you took the human neocortex and stretched it out, it's about the size of a table napkin, and it's still a thin structure. It's about the thickness of a table napkin. But it has so many convolutions and ridges, it's now 80% of our brain. And that's where we do our thinking. And it's the great sublimator. We still have that old brain that provides our basic drives and motivations, but I may have a drive for conquest, and that'll be sublimated by the neocortex into writing a poem or inventing an app or giving a TED talk. And It's really the neocortex is where the action is. 50 years ago, I wrote a paper describing how I thought the brain worked, and I described it as a series of modules. Each module could do things with a pattern. It could learn a pattern, it could remember a pattern, it could implement a pattern, and these modules were organized in hierarchies, and we created that hierarchy with our own thinking. And there was actually very little to go on 50 years ago. Led me to meet President Johnson. Been thinking about this for 50 years, and a year and a half ago I came out with a book, How to Create a Mind, which has the same thesis. But now there's a plethora of evidence. The amount of data we're getting about the brain from neuroscience is doubling every year. Spatial resolution of brain scanning of all types is doubling every year. We can now see inside a living brain and see individual interneural connections connecting in real time, firing in real time. We can see your brain create your thoughts. We can see your thoughts create your brain, which is really key to how it works. So let me describe briefly how it works. I've actually counted these modules. We have about 300 million of them, and we create them in these hierarchies. So I'll give you a simple example. I've got a bunch of modules that can recognize the crossbar to a capital A, and that's all they care about. Beautiful song could play, pretty girl could walk by, they don't care, but they see a crossbar to a capital A, they get very excited, and they say crossbar, and they put out a high probability on their output axon. That goes to the next level, and these layers are organized in conceptual levels, each is more abstract than the next one. So the next one might say capital A. That goes up to a higher level, it might say apple. Information flows down also. If the Apple recognizer has seen APPL, it'll think to itself, I think an E is probably likely, and it'll send a signal down to all the E recognizers saying, be on the outlook for an E, I think one might be coming. The E recognizers will lower their threshold, and they see some sloppy thing, could be an E, ordinarily wouldn't think so, but we're expecting an E, it's good enough, and yeah, I've seen an E, and then Apple says, yeah, I've seen an apple. Go up another 5 levels, and you're now at a pretty high level of this hierarchy. It'll stretch down into the different senses, and you may have a module that sees a certain fabric, hears a certain voice quality, smells a certain perfume, and will say, my wife has entered the room. Go up another 10 levels, and now you're at a very high level. You're probably in the frontal cortex, and you'll have modules that say, that was ironic, that's funny, she's pretty. You might think that those are more sophisticated, but actually what's more complicated is the hierarchy beneath them. There was a 16-year-old girl, she had brain surgery, and she was conscious because the surgeons wanted to talk to her. You can do that because there's no pain receptors in the brain. And whenever they stimulated particular, very small points on her neocortex, shown here in red, she would laugh. So at first they thought they were triggering some kind of laugh reflex. But no, they quickly realized they had found the points in her neocortex that detect humor, and she just found everything hilarious whenever they stimulated these points. You guys are so funny just standing around was a typical comment. And they weren't funny, not while doing surgery. So, how are we doing today? Well, computers are actually beginning to master human language with techniques that are similar to the neocortex. I actually described the algorithm, which is similar to something called a hierarchical hidden markup model, something I've worked on since the 90s. Jeopardy is a very broad natural language game, and Watson got a higher score than the best 2 players combined. It got this query correct: a long, tiresome speech delivered by a frothy pie topping, and it quickly responded, what is a meringue harangue? And Jennings and the other guy didn't get that. It's a pretty sophisticated example of computers actually understanding human language, and it actually got its knowledge by reading Wikipedia and several other encyclopedias. 5 to 10 years from now, search engines will actually be based on not just looking for combinations of words and links, but actually understanding, reading for understanding the billions of pages on the web and in books. So you'll be walking along and Google will pop up and say, Mary, you expressed concern to me a month ago that your glutathione supplement wasn't getting past the blood-brain barrier. Well, new research just came out 13 seconds ago that shows a whole new approach to that and a new way to take glutathione. Let me summarize it for you. 20 years from now, we'll have nanobots, because another exponential trend is the shrinking of technology. They'll go into our brain through the capillaries, and basically connect our neocortex to synthetic neocortex in the cloud, providing extension of our neocortex. Now today, I mean, you have a computer in your phone, but if you need 10,000 computers for a few seconds to do a complex search, you can access that for a second or two in the cloud. In the 2030s, you need some extra neocortex. You'll be able to connect to that in the cloud directly from your brain. So I'm walking along and I say, oh, there's Chris Anderson. Oh, he's coming my way. I better think of something clever to say. I've got 3 seconds. My 300 million modules in my neocortex isn't going to cut it. I need 1 billion more. I'll be able to access that in the cloud. And our thinking then will be a hybrid of biological and non-biological thinking. But the non-biological portion is subject to my law of accelerating returns. It will grow exponentially. And remember what happened the last time we expanded our neocortex? That was 2 million years ago when we became humanoids and developed these large foreheads. Other primates have a slanted brow. They don't have the frontal cortex. But the frontal cortex is not really qualitatively different. It's a quantitative expansion of neocortex. But that additional quantity of thinking was the enabling factor for us to take a qualitative leap and advance language and art and science and technology in TED conferences. No other species has done that. And so over the next few decades, we're going to do it again. We're going to again expand our neocortex, only this time it won't be limited by a fixed architecture of enclosure. It'll be expanded without limit. That additional quantity will again be the enabling factor for another qualitative leap in culture and technology. Thank you very much.
He did say cloud a couple times.
Okay. Well, if anybody doesn't know who Ray Kurzweil is, like I said, he's the head of Google's engineering and a big proponent of artificial intelligence. He was the one who invented, he's an inventor. He invented the first voice synthesizer. He invented, I think, the first music synthesizer. Well, you could hear Peter Frampton in the old days using that on stage. Anyway, he's written quite a few books, of course, and he's brilliant. I admire him a great deal. He's basically saying at the end how we're going to be using the cloud to enhance our brains in the future. And we're going to be connected to the cloud without needing a smartphone.
Man, what about them wireless? What about them pods up there you're sticking in your brain?
He was talking about the nanobots. Yeah, they're working on those now, and they're experimenting with
They're in
them.
our brain?
Well, they're not in our brain right now, but there's a good chance that in the future they will be. Any other questions?
So how do you use the cloud to do computing?
Well, I kind of outlined that in the handout that when you're using Facebook, you're using the cloud. Facebook exists on the cloud, and your interactions there, whether you're conversing with people, commenting on their posts, uploading pictures, or downloading their pictures, you're using the cloud when you do that. And it's Facebook's computers as well as your own. You're connected.
So that's what you call computing.
That's cloud
Usage
computing.
of storage and retrieval.
Yeah, that's part of it. But like I said about the games, if you play games online, you ever play a Facebook game or any other game online, that game exists out there on the cloud on some other company's servers, and you're playing it on their computer and using their computer to play it, as well as your own.
But that existed many, many years ago before we called this the cloud, right?
No, some people have always called it the cloud. We just didn't know it.
Okay.
Like I said in the handout again, ARPANET used that diagram of the cloud early on before the internet really existed.
So if I want to do income or a program to take care of my checking account,
Yep.
what do I have to have to get that on from the cloud or on the cloud?
You would only have to really sign into your bank's website. I personally do online banking. I trust the internet, I trust my bank.
No, I'm talking about like we do our bookkeeping.
Yeah.
I want to do a bookkeeping program. I want to create all these accounts, I want to post information, I want to retrieve information.
Okay, then I recommend
Do I
it.
have to pay somebody for that service?
No. No.
How would I find it?
You can use, like I mentioned, some of the other people that provide that free storage online would be Microsoft is one, Google's another, Dropbox is another. I'm sorry, what?
He has a Google account.
Yeah, and if you got a Google account, then all that stuff's free and available to you. You can use, like, here to show you. This, on my machine. You see over here where the Google Drive thing? That's the storage, right? Google Docs is free, Google Sheets is free, Google Slides are free, and those are all going, when you create using those, will exist on the cloud on their servers. And you can make them publicly available.
Basically storage.
No, I'm
Not
saying that's
computing anything.
those are creation tools too. They're not just something so you can look at things, you can actually create with those.
Thank you.
Yeah.
I think he's asking you more fundamental questions.
Maybe I'm
I think
missing
he's
it.
asking you a question about, let's suppose you want to, instead of using existing pieces of software like that, you want to create a program, for example, to analyze the structure of galaxies or something.
I see.
And so you're starting from basic scratch
Uh-huh.
to design something that's going to do something that didn't exist before.
Right, if you were a programmer. Okay, I
think
did miss
that's
that
kind of
part.
what you're asking.
Well, I want to know how much computing is actually done as opposed to storage.
Dave, what I was,
I'm still confused.
one idea would be to use something that already exists, such as QuickBooks Online
Mhm.
for financial use, which is what you mentioned, or Intuit, for example. I don't know what the online options are with Intuit, but QuickBooks has an online version which you can access through the web, through the web browser. So that would be one option, I think, for doing what you were talking about, as a financial application.
Is it free?
No.
Well, most of the time that's free. John would tell you, they're, whatever, like Intuit, QuickBooks, they'll usually charge for those, but there's always an open source alternative that's going to be available that's going to be free. Like I use over here, you can see at the top left, Open Office, that's free. It's the same thing as the Microsoft Office Suite, but it's free.
Yeah, but that resides on your computer.
Yeah. But it works in conjunction, like I said, with Google's offerings too.
Okay.
Actually, David, LibreOffice now has a cloud app. And you use their computer in the cloud, in these racks,
Mhm.
for a short time to do your Word document, etc., or your spreadsheet.
So I could use a very simple device to communicate,
Uh-huh.
and all that device has to do is be capable of displaying an active screen.
Right, and all the work is done in the cloud and ships back to you as a result.
I didn't.
Mary Frances.
Davy Rouse will be angry when we get home because of my saying this.
Okay.
But I have to. If John Kennedy were here,
Uh-huh.
he would say, classes have been offered here at Licking County Computer Society on cloud computing. The wife took the classes, the husband did not, and they were available to him. We have many classes that are announced to you on the internet and on our website. You all do not take advantage of them. You could, and now you come to those meetings and you don't know the answers to questions that you could have already learned. Yeah.
You paid her a lot of money for this.
So, just good, I guess.
Okay, as I mentioned again, on the Facebook pages, we have a Facebook page and a Facebook group. I encourage you to look for those and join them. We're doing pretty good outreach with those now. I think the average I saw for outreach was about half of our, it was around 37 to 40 people on any given average day a month. So that's not too bad. And we've been more active since they put me in charge of being able to post stuff. So I've been posting more things. And so if you want to watch the videos yourself, they're going to be available on the Facebook page. That's the idea. And you've got the handout there too. So. Anything else? Yes?
The presentations, both videos really focused mainly on cloud computing.
Mm-hmm.
But the topic for today is cloud computing and storage.
Mm-hmm.
So we really haven't talked much about cloud storage.
I did before I showed you the videos. I was showing you how I use cloud storage with Chrome and my contact list and all that.
Yeah, that's kind of.
And I have you also. I'll show you another one here. I have Google Photos. That's free. Where I do photo uploads. If I can get this up again. Here we go. Up here. It's always you can find these things here in that little grid square thing. Just click on that. Oh, that's the wrong one. Let's go here then. That's everything you do. I think we got a slow internet connection.
Mitchell?
Yeah.
What's one?
Yeah, I was trying to answer his question. Now, here it goes. I'm working again. Oh, there it goes. There it goes. There it goes.
I understand what you said about favorites in your browser and syncing, having your favorites synced across devices by using Chrome.
Right.
That's what you talked about.
Right.
Okay, but what about saving files? Can we create?
Okay, Google Photos is a good example of that, right? So I'll
What
click
about
on.
word processing files, spreadsheet files?
That's where, when I mentioned earlier to Davey about those tools that Google makes available, along with their Google Drive program, they also have the Google Docs, Google Sheets, those are enabling you to use the cloud to create and store each of those kind of documents.
Okay, what if I don't want to use Google Sheets? What if I'm not using Google Sheets and Google Documents? I'm using software on their computer to create spreadsheet files and Word files. Okay, if I want to share those across devices, how do I do that?
Like this, the way I uploaded, like show you, or like I use Google here.
You already know the answer?
If I go to my,
Oh, okay.
the way I
He
did,
knows the answer.
oh, he knows the answer.
I'm trying to roll it.
Oh, to help other people, I guess, right? Well, I'll give you the example would be how I uploaded the handout to Google Documents and made it publicly available, right? So, oh, it's not on here, it's on the PC at home. But anyway, if I had a document,
Let me elaborate on
I
this.
could drag and drop it into Google Docs, and it would upload to Google Docs, and then it would be, I could make it publicly available if I wanted.
Okay. But suppose I'm working on files. Suppose I use different computers.
Okay?
Like, this may apply. I would think of maybe they're using different computers and maybe in different locations. And they want to access the files that they created on whatever original computer they created those files on. They want to be able to access those files on a different computer and update those files.
You would upload them to something like Google Drive, and you can access that from anywhere.
Yeah. Right. So that's either Google Drive.
You wouldn't even need your own PC. You could go sign in at work and get them.
Exactly.
Yeah.
That's what I'm saying. That's what I'm getting at. For cloud storage, some options would be Google Drive or
Microsoft's OneDrive, Dropbox, yeah, all those. And most of them give you quite a bit of storage. I think Google gives you 15 gig free.
I don't know about that, but yeah, they do get quite a bit of storage. For most users' needs.
Oh, yeah, it's more than most would need.
Yeah.
Mary Frances again.
I know. Didn't you promise me that you would tell them all this fact? If somebody's sitting here listening to this fact that there is plenty of Google Cloud storage out there available to you, and you're thinking, I'm not going to go over to Staples and buy myself that new $115 external hard drive with its 3 terabyte storage, because I want to make an image of my whole computer and everything that's on it. I'll just put my image on a cloud. There's plenty of room.
No, if you want that much room, you're going to probably end up paying for it.
Why would they not want to do that, Mitchell?
That's not going to be available for free.
That's
Is
not
the
going to be
idea.
available.
Like I just mentioned, Google will give you 15 gigabytes free, but that's not enough to store the image of your whole computer.
Okay, even if I had purchased enough, they say that for an ordinary computer and the storage you would need, that it would take you 3 weeks to download it back down to use it if your computer crashed and you wanted that information. So there are certain restrictions.
No, it wouldn't. Like I said again, if you're only going to use 15 gig, I guess it depends on the speed of your internet connection, but you can do 15 gig in about, I don't know, 3 hours.
It would take you longer to upload. It would take that long to upload.
It'll take you longer to get up than we'll learn to bring it down, exactly.
Yeah. Either way, they say it's really not advisable. For large.
Yeah.
When your taxes are a big example of this, TurboTax.
Mm-hmm.
You can pay TurboTax, and then you can go out to their server and tell them about you. And their server then knows all the banks that you do business with. They know all the companies that you work for, et cetera, et cetera, et cetera. And then TurboTax, from their server, contacts all the servers of all the banks and all the companies and all the organizations that you have dealt with during that year financially. And it gets all, each of them has the database that has your current position, your bank account, your investments, how much you've been paid last year from many companies that you may have worked for, and it sends back to TurboTax all of the 1040s, etc., 1099, you name it, from their servers. And this is the cloud computing. And then TurboTax, its server, puts everything together, sends it all back to you. And you could print it and mail it in, or you could have them email it to the government electronically to their server, who would file it away with your tax that you pay. That is cloud.
Yeah. Another one I mentioned is banking. I do my banking online. I pay my bills online. I pay Walmart online.
But everything changes like that.
And so I'm using
And there's only one
their
database.
computers to do it, is the idea.
There's
Take
only
care of
one
business.
database that knows your current position or your position at the end of the year for taxes. And that is the one database for each individual bank. And you have to contact them to get the real figure. You may think that you have so much money, but you don't really know unless you have the 1099 or whatever.
Any other questions? Yeah.
Again, about the cloud storage. Now, hardly know enough to even ask the question. At home, I do a piece of work, I can save it on my hard drive of the computer, or I can send it to the thumb drive, and I tell it where to go. When I bought this phone, it's an Android, 2.5 years ago, they said, oh, you get 5 gig of cloud storage with this phone. 32 gig hard drive. Now, it's maxed out with video and film, so I can't really do much with it. But periodically, after a year or two, your cloud storage is full. You want more. I keep saying no, no, no. A month ago, I got a thing that said, we're going to start charging you for your cloud storage. Get it off there by the 19th of January or something. Well, I didn't do anything. I don't know how to do it. So whatever's on the cloud has been lost. But how did my stuff get on the cloud? I never sent it to the cloud.
It depends on who ran the phone, who you get the phone
It's a
from.
Verizon phone.
Verizon, yeah. It was probably a Verizon cloud then, and they may have discontinued that service.
Well, so am I assuming that the first 5 gig of photos or whatever I did went to the cloud and my hard drive here?
If you bought it at Verizon, it would have been pre-set up. When you bought the phone, it was already activated. That's how they do things.
Okay, so the cloud has stuff on it and my phone has stuff on it, and a lot of it is the same stuff, I guess.
Google would give you more space. If I were you, I would try to retrieve what you could and upload it to Google instead. Do you have a Gmail account?
Gmail.
You got Google Drive.
Okay, well, what I'm trying to do is just offload to my thumb drive on my computer and let stuff off of here and do it that way.
The nice thing, and this is a good demonstration, this is a Google Photos app. It's on the cloud, right? These pictures that you see, if I scroll, I can page down here. I don't know, but all the pictures that are listed here, these pictures are on my laptop. They are not on my laptop. There's pictures of my cat. There's a picture of my cat. See, they're not on my laptop. They're on Google Photos in the cloud. So I can look at these pictures from any device I have, anybody's computer I have. If I sign in and look,
Right,
sit
so
and look at
what he's saying is, he doesn't know what they went to.
Something's on a cloud that's maxed out.
It's probably Verizon is where it went. I'd have to look at your phone, I guess, to figure that out.
Google, that's Google's. I got Gmail.
Google gives you more than 5 gig though. They give you 15.
Google gives you unlimited for photos, but for other stuff like Docs, you get 5, I think it is. Unless you can get a second email address and take that 5.
I'd have to look at your phone to find out. I would.
Well, when I go see my data, or not my data, whatever, my storage is 32 gig, 8 gig for the programs that runs, and then the other 8 and 32 is 24 storage, 24 gig of storage here, I guess.
And I'm not the only tech-savvy person here. Ken Bixler or these guys, they all know what they're doing. So you could bring it in on one of the repair sticks Saturdays, and they could look at it for you too.
I'm using Microsoft OneDrive.
Yep.
I started using it on my PC.
Yeah, I know.
Yeah, okay.
Can we get a little quiet and take the side conversations outside? Thank you.
Okay, so I started using Microsoft OneDrive at home. I discovered later that I could use OneDrive, Microsoft supported Android for OneDrive. So I can access my files now on a tablet. I have an Android tablet. I can access those files on my tablet. It also installed OneDrive on my phone. So now I can access the files on my phone. Microsoft also has a free version of Word and Excel and PowerPoint for Android. So I can open my spreadsheet files, my word processing files on my tablet and my phone. So this works, this is really
Yeah,
good.
and Microsoft has basically the same kind of offering that Google does. Yeah. A lot of free stuff. Let's go to Jim. I think he's getting anxious for the ticket thing.